Any question about the last lecture? But it's not capturing. Can you on it? So where were you, my friend? It's lecture number 7. I'm asking you, this guy. Yeah. Any question about the last lecture? We discuss about the module, we discuss about coupling, we discuss about cohesion. Yes, coupling and cohesion. Mr. Darvesh. Off the monitor. Yes, my friend. Coupling. Dependency. Not independency. Dependency. When a system or application or component needs from another the help to perform its task, then we have coupling. And cohesion, Mr. Abdul Rahman, Mr. Khalid, Mr. Jamal. Cohesion is the opposite, versus, vice versa, or reverse. When a module doesn't need the help of any other module, independent, to perform its task. Example of cohesion. Yes, Mr. Muhammad. Example of cohesion. Any software example. Inbox. Example of coupling. Send messages. Needs the help of new or compose. Output of one becomes the input of second, or ATM. ATM system needs the data from another system to perform its function or job. This is what we discussed about the coupling and the cohesion in the last lecture. And we have the abstract classes, abstract functions, abstract methods. We already covered. Then we discuss about reusability. Reuse. Use anywhere. Write once, use anywhere, run anywhere. Example of reusability. Yeah, BMW, Mercedes-Benz software, or SAP, or COBOL based software, or FoxPro based software, written in 1980s, 70s. Still, you should be able to reuse. The main advantage is time saving, cost saving, testing, maintenance, everything, reliability, high reliability, because it is already thoroughly tested and maintained. Designing tools. Example of any designing tool? Example of any designing tool? Yeah. Mr. Khalid? Star UML. Any other? Rational rows. Any other? Any designing tool? Star UML, rational rows. Visio. Why so afraid? Visio. Together soft. ERWin. These all are designing tools. ERWin is missing. ERWin is also there. Entity relationship for Windows. Design and abstraction. They have relationship. We always have abstraction, because the use case or class diagram is abstract design for the programmer. Use case, class diagram or data flow diagram, DFD, ERD is abstract design for the programmer. To create views, we discuss about the view. What is a view? How to define view?
View database.
Oh, yes, but view is also there. Correct?
I think subset from data, subset from table.
Subset from table.
External view of that.
Rian?
So when you're looking to the system that has some privileges, for example, in Addis Plus, the employee when you log in is different from student.
Yeah. View is a virtual relation. View is a virtual relation that doesn't exist in the database, but it is generated from user's point of view. As he said, for the student, for faculty, for administrator, user view will be, student view will be different than the faculty view. Faculty view will be different from the administrator view. So every user, every category of user has a different view. What is the complete code? What is written? And breaking down a system into pieces, parts, modules. We already covered about the functional decomposition. Breaking down the main function into sub-functions. Why we need design? To have a clear-cut picture of the system, like architecture of a building, like architecture of a building, like a model, like a model. So you can simulate the real situation or the real system. Based on that, you will develop the actual system. Based on that, you will develop the actual system. So all the stakeholders, they can get agree on common design. Customer, team, board of directors, board of governors, users, they all are the stakeholders. So they can have common design. They can agree on common design. And we can concentrate, focus on one functionality that we want to display by using a form or report or whatever, or a table, and to have a user-friendly interface. User-friendly. So user can easily understand the screen or the form or the report, or they can use. Yes. User-friendly. User must be satisfied about the usage. He can easily understand what is the purpose of that screen and facilitate design reuse, not code. Code reuse is also there, but now we are talking about specifically design reuse. Can we reuse the design? How? Design reuse. Mr. Haitam?
We use the same class or abstract of the classes and from the previous one to make the new one.
Yes, good. You already have the class diagram. So you should be able to reuse the previous class diagram, classes. That is the reason we have a parent class and the child class concept. Superclass. What is superclass? Superclass, parent class. You already cleared 2 or 2, 2 or 3, huh?
Superclass is the bigger class from the subclass. We can use method, then take it from subclass.
A superclass is the parent class, or the main class, and it must have all the basic data and the functionalities. So when you design the class diagram, you have parent class and then you have the child classes. And for the similar system, you can reuse the previous design. Use cases, class diagrams, sequence diagrams, customization purposes. Then for the software, in terms of hardware, embedded software. What is embedded software? Embedded software. Yes, embedded software. Embedded software. Never heard about embedded software? Yes, Mr. Raziz. I covered 251.
Embedded software is software that runs without involve user. That's it.
A software that is engraved in electronic devices. Electronic device. For example, ROM. For example, mobile. Or car. Dashboard displaying. All the cars are now electronic system. They have sensors and everything. Fully automatic. Fully controlled by software. The CDI based.
It runs without involve user.
Yeah, it's all automatically programmed is there. For such physical hardware, you use the design like chip, or like computer, tablets. For such hardware devices, you reuse the design. That is the design reuse. Of course, class diagram, sequence diagram is there. But here we are talking about the hardware design. So you can have physical, the same copies, reuse. Like car. One model is accepted, then they start manufacturing the same model for Toyota, for Honda, for GMC, same copies, same CPU, I7, I7, I3, I4, I5, mobile, iPhone, Samsung, all same. That is the design reuse. Is it possible we don't have a design in the system? For commercial applications, it's not possible. For small programs, like academic programs, that can have no design, no problem. You can code directly without passing through the design phase. Just having the requirement and you can start the code. It is possible for small programs, not for commercial applications, because that have to be evolved. Those applications have to evolve. 1 year, 2 year, 3 year, 4 year, 5 years. Continuous. Evolutionary projects are there. So we have design paradigms. We have functional paradigm and we have object-oriented paradigm. So here our base is functions, procedures, methods, the base like C, C++, and then you have the object-oriented. The component relation is one function call another. We already covered the call by value and call by reference in the previous lecture. Mr. Khalid, what is call by value? Call by value. By value. Call by value. The normal call. Yeah. In the call by value, the original function preserve the copy original and provide the copy. And call by reference, original. Original is provided by address. So data can be changed. Like in a data structure. Like in data structure, you provide the actual address. The data can be changed. So we have abstraction. One function calls another function. So we have design strategy. We have top level design. We already covered the top down structure. And then refactoring. We have a concept refactoring. Yes, my friend. Refactoring. 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 How many types of refactoring we have? What is refactoring?
Make again.
We have two types of refactoring. We have design refactoring and we have code refactoring. Improve the design without changing the code. Optimize the design without changing the code. Optimize the code without changing the design. Improve the code but without changing the design. So we have design refactoring and we have code refactoring. So this is what called improve your design without changing the code. As much optimize you can. And then we have the object-oriented paradigm in which we have classes, we have state diagram, class use case, sequence diagram, and we have relationships. We have aggregation concept. We have composition concept. What is aggregation? Aggregation.
Relationship between
Siddharvesh? Have you heard about aggregation composition? So what is aggregation composition? You heard and you don't know. Mr. Ria? Yes, Abdul Rahman.
relationship between
So what is the difference between aggregation and the composition?
Over here, very
Hmm? Huh?
Strongly.
Strong. Yes, Rian?
Aggregation, the two classes have sharing their method to each other.
Hmm.
It is composition. I think it's separate.
Aggregation, composition. It is covered in 251.
No.
I showed you the computer and the CPU, motherboard, mouse, keyboard, the diagram.
Which
When we covered the classes concept, chapter 3, chapter 2. Yeah.
only cover the
After that,
yeah.
I covered aggregation and the composition.
That's
Yes, yes. The composition is the strong association. The component lives and dies with the parent. Child lives and dies with the parent. If child die, parent, nothing will happen to parent, but no more child will be there. So child survival is with the parent. Like for example, this room is associated with the FCIT building. So its existence is with the FCIT. If you remove this one, nothing will happen to FCIT. There are so many rooms. There are so many rooms. So this room lives and dies with the FCIT building. So you show it by red color. Diamond with red. Strong. FCIT is a part of King Abdulaziz. FCIT lives and dies with King Abdulaziz. If you remove one department, one faculty, nothing will happen to King Abdulaziz. King Abdulaziz has so many departments. So its survival part is with the King Abdulaziz as long as it is associated with King Abdulaziz. Alone it's nothing. Nobody knows about who is FCIT. Huh? We don't know about FCIT. We know King Abdulaziz University. And King Abdulaziz University has a department, Faculty of Computing and Information Technology. Same IT department under the FCIT. We have CS, we have IS. If you remove IS, nothing will happen to FCIT because two other departments are there. So I gave you 3 examples. Lives and dies with the parent. Strong association. Personal computer has so many components. CPU is there, motherboard is there, keyboard is there, mouse, monitor, all are there. They lives and dies with the computer. Strong association. You can change one keyboard to another keyboard. You can change one monitor to another monitor. Computer is there. So the part existence, survival is with the parent. That is the aggregation and the composition concept. The relationships. We have relationships like the ERD. Like the ERD. We have one to one, we have one to many to many. Yeah. One to one to many to many. And then we have inheritance. We have inheritance. The child inherits the features of the parent. The data and the functions, data and the methods. When you draw the class diagram or the object diagram, you have to think about the relationships. You have to think about the base class and the child class. The parent classes and the child classes. Subclasses.
From super.
Yes, superclass. So you have to show the relationship, inheritance. So we already covered about the abstraction. So design strategy, identify the basic objects, concepts in your application domain, select a design architecture, metaphor. Metaphor is abstract design. Add additional classes for desired functionality, abstract out superclasses to facilitate understanding and the possible reuse. When you have the superclass, the main, it's easy to reuse because it is containing the all data, the main methods and main data. You can have more child classes. They can inherit from the base class. So it's heavy class, base class. The platform is there, foundation is there. And the refactor is necessary. So functional, we have input, we have computation, and the output we already covered. And the object-oriented, we have the classes, and we have the state, session state diagram, and functionally designed but not simple. So in the design, we have analysis model and we have the design model. During the analysis phase, you have analysis model, and during the design stage, we have the design model. This is the analysis model. We have scenario based elements, we have flow oriented elements, we have behavioral elements, and we have class based elements. These are the four main things you need to consider for analysis model. And these are associated with the design model. If you see, we have interface design, we have architectural design, and we have class based design. Different layers of design are there. Interface, architecture, and the data and the class design. Let's see here for the data, we have class diagram, the packages, CRC model. Have you covered the CRC? CRC model. Anybody? CRC. CRC stands for Class Responsibility Collaborator. I should write on the board, I think. Class responsibility collaborator. This is CRC, and we use cards. Each card has class. What are the classes associated to that? And what are the responsibility of this class? And which classes are related to this class, associated relationship with this class. So you have a class responsibility on a card which is mentioning what are the main functions of this class and what are the collaborator class, what are the classes which are collaborating with this class. CRC card. It is used for modeling. To identify, finalize the class, functions, methods, and the collaborator or associated class. CRC model for the data or class design. Then the collaboration diagram. Did you cover collaboration diagram? Collaboration diagram. We are going to cover, inshallah. We will cover. It is like the sequence, but there is a difference in the sequence and the collaboration diagram. And then after this, architectural design. Architectural design cover with the data flow diagram or the context flow diagram or the processing, and then you have interface design, the use case diagram, we have swim lane diagram, state diagram are there. So these are the analysis model and the design model differences. So this one is linked with the both interfaces and with the architectural design. Any question regarding the analysis model and the design model? So it becomes the base for your design model. The analysis model becomes the base. On the base of that, you finalize the design model. During the analysis level, after requirements, you will do analysis model. And then you will go for design model. What is the difference between analysis model and the design model? What is the fundamental difference?
Analysis will say what the system will do and the design how it will do.
Excellent. Did you study the slides? Yeah, very good. Excellent. In the analysis model, we are actually finalizing what we are going to do. What is the problem? What is the problem? What are the functionalities? And the design, how you are going to solve the problem. How you are going to solve the problem through the interface architecture and the class design. This coming in the next slide. In the analysis model, the problem that the software will try to solve. While in the design, I will explain how I am going to solve this problem. See, why we should imagine the two domain, the problem and the solution domain. Analysis is the problem domain and the design is the solution domain. Remember the definition of design? What I covered in the first lecture after the software definition. Yes, generating alternative solutions of the problem and selection of the best one. See, it's here. So you will design alternative designs. All the stakeholders will sit together and finalize the best design for the system. I think we will cover this one in the next lecture because time is up. Any question?